So in the previous video we discussed how we transform this phi or delta circuit into a T or Y circuit, and these are the relationship of transformation. R1, R2 and R3 can be written in terms of RA, RB, RC. These are the three equations. So now with these results, now let's move to how we do the transformation in reverse manner. That means if we have given this T or Y circuit, then how we will transform it into phi or delta circuit like this. So then what it means, RA, RB and RC must be written in terms of R1, R2 and R3. Here R1 and R2 and R3 has written in terms of RA, RB and RC. So what we should do is the reverse. So now we will do it. And now I will draw circuits here. So this is R1, this is R2 and this is R3, and then we must transform this into this kind of a phi or delta circuit, just like this. Here I will write R A, R B, R C. Okay, so I'm using my laptop's touchpad and the mouse, so that's why these things are quite deforming always. So I will soon take an interactive pen for these purposes, and you will soon see some more better images and more better drawings and writings. Now these are quite deformed and ugly, but I think you will excuse me for that. For now I will soon refix those things. So now okay, then what is R1? R1 is equal to R A R B divided by R A plus R B plus R C. So these are the results, and these are okay. Then R2 is R B R C divided by R. Okay, I will copy them. And then what is R3? It is equal to R A R C A R C divided by this one. So these are the results, and I will put them. This one, this is 2, and this is 3. So I will put them much manner. I will put number 3 because this is R3, and I will put number 1 to this equation R1, and I will put number 2 because this is R2. So what we must do is, so now keep these things in mind, and then I will write the product of all the resistances in this circuit that we want to transform into this circuit. So write R1 into R2 plus R2 into R3 plus R1 into R3, which is equals to, now we have to deal with these three equations. So R1 into R2 is what? R1 into R2, RA into RB into RB into RC. So what is that? RA into RB squared into RC. RA, RB, RC by this. So that is RB squared, and then I will copy these things for my use, and then plus, it's quite messy, plus RC divided by, and this is what? R2 into R3. R2 into R3 means, okay, R2 into R3 means RB into RC into RA into RC. That means RA into RC square into RB plus, so that is RARC squared, then plus then R1 into R3. R1 into R3 means RA into RB into RA into RC, RA squared into RB RC. So I will write RA squared here. So now I will take the common factor. So these are squares because it's the same denominator. I'm sorry for that. Okay, then I will take the common factor out. So RC divided by RB plus RC in squared is its common factor. Then I will take this factor to outside. Okay. This is RC. So I took the factor to the outside, and then what will be inside the brackets. RA, RB, RC. If I take it out, then here RB remains, here RC remains, here RA remains. Then it is the sum RA plus RB plus RC. So now we can cancel one of them, and so what we'll take now is this is equals to this one, the product of the resistors in the phi or delta circuit divided by the sum of the resistors in the phi or delta circuit, and find it. Okay, then this was the result we finally obtained. And now what we can do here, so what we can do here now, here we can do, now assume that if we divide both sides by R1, then the R1 is this RA RB divided by RA plus RB plus RC. So we can eliminate two of these factors and this denominator completely. So what I am going to do is divide both sides by R1. Yeah, divide by R1. So what is R1 here? According to, we discussed it, and it's R1. This is R1. So you see R1 from equation 1. Okay, then substitute this thing to this, to here, both sides. Then the output will be, so I'm not going to substitute here because I want to keep R1 here, and instead I will substitute R1 at here, R1 at here. So now I will copy these things. R3, and that's equals to this part into 1 upon this one. Upon this one. So now what we can see here, this one to this one cancel, this one to this one cancel out, and RA RB here RA cancels to RB, RA, then RB cancels to RB here. The remain is RC. So we can, now we can see we have some relationship. RC is equals to this one. Where's R here? Wrong. So this is the relationship that we obtain at first. For RC can be written in terms of R1 and R2 and R3. Here RC can be written in terms of R1, R2 and R3. So now we have already transformed our circuit, so we want to write the remaining RB and RA. Then RB can be written as this product sum, this product sum divided by, so what is the resistor? So here in order to find RC, we divided the product sum, which is a constant, and divided it by R1 for RC. So now let's see the pattern of doing it. So in RC we want to find RC, then we done it by multiplying, taking the product sum, which is a constant always in a certain circuit, and so divided that by R1. So that means if we want to find RC, this is the right hand side. RC is in the right hand side, so look at the right hand side here. Then the opposite side to the right hand side is here, so the resistor in that side is R1. So then that's why we divided this whole sum product by R1. And now we want to, if we want to find RB, then look at the RB side. Then if you want to find RB, then look at the RB side, in the corresponding side in Y circuit, and look at the opposite side. And here the resistor is R3. So then we must divide the product sum by R3. Then so we divided it by R3. Similarly, we can RA can be written as the product sum divided by R2. So let's take a look. So here, if you want to find RA, then look at the side of RA. Then this is the side of RA. So look at the corresponding side. So if you want to find RA, then look at the corresponding side, and here the corresponding side is this, that means left hand side. So look at the opposite side, so you will find R2 resistor. So we must divide the sum product, this product sum, by R2 resistor. So we done it. Okay, now we have found the relationship of transformation. Write it again. B. Oh no, it's R C. Okay, then these are the relationships that we want to be used when we are doing what is we are transforming T O Y to pi or delta. So this is the transformation formula. So now let's move to an example to make it clear. Okay, then assume that we have given a resistor combination of a in Y circuit just like this, and here R1 I take 2 ohm, and here I will take 3 ohm, and here I will take 6 ohm. So I want to transform this circuit into this pi or delta circuit. So this is R1, this is R2, this is R3. I will take them as like them. So R1 can be written as how R1 can be written as. So if you look at the R1 side, then look at the corresponding side, then look at the opposite side. Here 3 is the resistor. So then what you have to do is take the sum of all the products of this resistor combination. So it's 2 into 3, this one into this one, this one into this one, this one into this one. 2 into 3 plus 3 into 6 plus 6 into 2 divided by, so what's the rest? R1, so divided by 3, here 3. So the resistor value we will have is here 2, here 6, 8, here 4, 12 ohm, 12 ohm. Okay, I think I'm correct here. 2 and 6, 8, and then 4, 12. Okay, then what is R2? R2 is the same product sum, it will not change. Divided by, so now R2 is here, R2 is here, so look at this corresponding side and look at the opposite side. Here 6, should divide this thing by 6. I can do 6. So answer will be 1 minus 3, sorry 2 minus 3, oh no, 1 minus 3. I'm quite crazy at some moments. 1 minus 3 plus 2. Minus 3 plus 2, that is here R2, take as 0 and okay, then R3 will be what? So the same product. Oh, what I have put this minus value. So 1 plus 3, 4 plus C, 2, 6 ohm. This is 6 ohm. Please forgive me. It's quite sometimes I miss 2 bits, so don't care about it. And then must take the product sum again and divide it by R3. So R3, for finding R3, so look at this side. So opposite is 2 ohm divided by 2. So the answer will be 3, then 9, 12, 18. Okay, then these are the transformed resistors. So I will put the values here. R1, so what? R1 was 12 ohm, R2 6 ohm, R3, what the heck is R3? It is 18 ohms. Okay, then it is 18 ohms. So that's how we done the Y to phi delta transformation. So that's how we done, and we have these are the equations that we used for the transformations. So I hope that you will understand what am I saying, and so I think that you may have taken many knowledge through this, and I may have lots of mistakes and lots of lack of facility, so please forgive me. I will soon fix them, and I think you will appreciate my work. And if you are interested, if you are well with this, so please be kind enough to subscribe and like my channel. So thank you very much for everyone who watched this. Thank you very much.